Have you ever just stopped and wondered how a tiny bird finds its way across an entire continent? Or how an ant marches in a perfectly straight line with, seemingly nothing to guide it? We see these things all the time, but we don't always appreciate the hidden senses and biological superpowers that make it all possible. And honestly, they're absolutely mind-blowing. So let's dive into this incredible unseen world of animal navigation. But first, let's start with something a little closer to home, our own brains. Let's say I asked you to memorize a long list of random things. It'd be tough, right? Well, what if you used the journey method? You'd picture yourself walking through your own house, and you'd place each item in a different room. An elephant in the bathroom, a lion in your bedroom, maybe a giraffe kicking back on the sofa. All of a sudden, it's way easier to remember. And that trick works so well for one simple reason. Our brains, like those of all mammals, are just naturally fantastic at creating and remembering spatial maps. This is our first clue. Our brains are fundamentally wired for navigation. So, here's the plan for our own little journey today. We're going to start with what's familiar, that GPS built right into the mammalian brain. Then, we'll explore how some animals can see a hidden world of information in light itself. From there, things get, well, a little weird as we dive into the quantum compass. And finally, we'll see how all of these amazing systems come together in one of nature's ultimate navigators.
All right, first up, let's look inside the brain. Our knack for building these mental maps comes from a really tight partnership between two key areas, the hippocampus, which is our memory hub, and a place called the entorhinal cortex, which is basically mission control for spatial reasoning.
And what researchers have found inside that entorhinal cortex is just a stunningly sophisticated toolkit. It's got all these different neurons that each have a very specific job. You've got place cells that only fire when you're in one particular spot. Then there are grid cells, which act like your brain's own internal graph paper, creating a coordinate system. Border cells fire when you get near a wall or an edge. You've got head direction cells, that's your internal compass, and even speed cells that track how fast you're moving. It's this whole team of specialists working together to build a dynamic map of your surroundings in real time. It's incredible.
But here's where it gets really interesting. As much as we know about these amazing, specialized cells, they only make up about 41% of the neurons in this part of the brain. For a long time, the other 59% were a total mystery. And it turns out the brain isn't as rigid as we thought. A lot of these other neurons are multitaskers. They're flexible, responding to a bunch of different things at once, even non-spatial stuff like the pitch of a sound. And this flexibility is the key. It suggests our internal GPS is way more powerful and adaptable than we ever gave it credit for. Okay, so that internal map is fantastic, but it's only one piece of the puzzle. For our next step, we're going to look outside the brain at how some animals use external cues that are completely invisible to us. Think about it. That complex internal GPS is great if you're a mammal. But what if you're an insect with a much simpler brain? You can't rely on all that complicated hardware. You need a totally different strategy. So how do you find your way around when you don't have one of those intricate mental maps?
Well, you tap into a hidden layer of reality. See, when we look up, we just see sunlight as brightness. But many insects can see its polarization, basically the direction the light waves are vibrating. As sunlight scatters through our atmosphere, it creates this huge, predictable pattern of polarized light across the entire sky. And for an insect, that pattern is a giant celestial compass, one they can use even when the sun is totally hidden by clouds.
And their eyes are brilliantly designed for this. You can almost think of an insect's eye as being split into two different tools. The upper part, the dorsal rim area, is just packed with special cells for reading that compass in the sky. It's always looking up, checking their heading. Meanwhile, the lower part of their eye, the ventral retina, is aimed down, looking for polarized light bouncing off of surfaces on the ground. And the way they use those reflections is just wild. A dragonfly sees this specific way light polarizes when it bounces off a pond and knows, aha, perfect place to lay my eggs. A backswimmer bug, while flying, will spot that same polarized glare and just perform a perfect dive, because it knows that's water. And get this, blood-sucking horseflies can find animals because the light reflecting off their fur is polarized. To a horsefly, a big, dark-colored horse is just a giant, delicious polarized beacon.
Okay, we've talked internal maps. We've talked seeing invisible light. Now we're going somewhere that sounds like it's straight out of science fiction. We're going to talk about navigating with quantum physics.
I mean, just imagine for a second. You're deep underground, or it's a completely moonless, starless night. Your internal map is blank. There's no polarized light to see. Nothing. How could any living creature possibly know which way to go?
This quote just nails the mystery. For ages, we knew some animals could sense the Earth's magnetic field. The obvious assumption was they had tiny iron-based compass needles somewhere in their bodies. But for lots of insects, like ants, that just wasn't true. Scientists looked, and there was no detectable magnetic material. So, they were using a compass made of something else entirely.
And the prime suspect for this mystery compass is a protein called cryptochrome. These are light-sensitive molecules found in the eyes of all sorts of animals. Insects, birds, you name it. We already knew they helped regulate things like daily rhythms, but scientists now believe they have this jaw-dropping second function. They allow an animal to literally see the Earth's magnetic field.
So how in the world does a protein sense magnetism? Okay, stick with me, because this is where it gets wild. It's a quantum process called the radical pair mechanism. Here's the basic idea. First, a particle of blue light zaps the cryptochrome protein. That jolt of energy creates something called a radical pair, basically two molecules that are connected by a pair of electrons whose quantum spins are linked. Now, these tiny electrons are spinning, and their spin is incredibly sensitive to the Earth's magnetic field. The field makes them wobble in a specific way that changes depending on which direction the animal is facing. This wobble affects the protein's chemistry, creating a signal the brain can actually read. They're basically seeing a pattern, an overlay on top of the world, that shows them the direction of the magnetic field. It's a true quantum compass.
Okay, so we've got an internal GPS, a polarized light compass, and a quantum compass. Let's put it all together and look at one of the most astonishing navigators on the entire planet, the monarch butterfly.
Every single fall, millions of monarch butterflies from all over eastern North America fly thousands of kilometers to one specific tiny patch of forest in central Mexico. But here's the truly unbelievable part. The butterflies making that journey south have never been there before. They're several generations removed from the last ones who were there. The directions aren't learned, they're just in them. It's genetically programmed.
So how do they do it? Well, one of their key tools is a time-compensated sun compass. This means they don't just fly towards the sun. They instinctively know that to go south at 10 in the morning, they need to keep the sun on their left. At noon, it should be straight ahead, and at 2 p.m., it needs to be on their right. To pull that off, they need to do more than just see the sun. They need to know what time it is.
And that's where their internal body clock, their circadian clock, becomes absolutely critical. It's not just helpful, it's essential. In experiments where scientists mess with the monarch's clock by keeping it under constant light, it completely loses its ability to orient. It just follows the sun across the sky, flying west all day, because it's lost that crucial timing information it needs to correct its course.
And this diagram gives us a peek at the incredible brain wiring that makes this all possible. You can literally see how the different systems are connected. The signal from the circadian clock, that's the PL here, is talking to the central complex, which is the sun compass itself. And you can see that the compass is also getting input from the dorsal rim of the eye, where it's sensing that polarized light. It is a perfectly integrated navigation machine.
So let's just recap the monarch's insane toolkit. They've got the sun compass, which is perfectly calibrated by their internal clock. They can use polarized light as a backup for cloudy days. And yep, they have those cryptochromes, which means they are almost certainly using a quantum compass too, maybe as a backup or to help calibrate the whole system. They're using pretty much every amazing trick we've talked about today.
So why does all this matter? I mean, besides being just unbelievably cool. Well, because understanding this biology is inspiring a whole new way of technology. Engineers are actually trying to build artificial quantum compasses based on this exact mechanism. Just imagine, tiny, super low-power navigation chips for drones or robots that could work underground, deep underwater, or anywhere else GPS signals can't reach, all by sensing the Earth's magnetic field, just like a butterfly. And that kind of leaves us with one final big thought. We've just seen that some of the smallest creatures on Earth are masters of quantum mechanics, using it for something as basic as finding their way home. It really makes you wonder, right? What other profound secrets about how the universe actually works are out there, hiding in plain sight, being used every single day by the animals all around us?